For this standard, we are going to use an area model to multiply polynomials. This will help us express the area as a sum and as a product. Let's start with an area model has been given to us, and we need to fill it in and use the components to express its area as a sum and a product. First things first, I'm going to fill in each of the 4 boxes of my area model with their respective areas. To do this, I multiply the length and width of each box. For instance, in the bottom left corner here, the length is 3x and the width is 4x. When I multiply that together, I get 12x squared. Remember that when we're multiplying terms with coefficients and x's, the coefficients multiply together. That's how we got 12. That's 3 times 4. And then the x's multiply together. X times x is x squared. Now I continue to fill in the areas of the 3 remaining boxes. 2 times 4x is 8x. 3x times negative 5 is negative 15x. And last but not least, 2 times negative 5 is negative 10. Great, so now we have what we need to write our area as a sum and our area as a product. We're going to do the area as a sum first. When I look at my area model, I want to check for like terms. So I have 12x squared, but none of the other areas have an x squared. So I write 12x squared. Next, I look at 8x. Well, 8x and negative 15x are like terms because the x's both have an exponent of 1, right? There's just x. So when I combine that, I get negative 7x. Last, I have negative 10. There are no other constant terms in this area model. So I add that to my area as a sum. And we see the area as a sum is 12x squared minus 7x minus 10. To write the area as a product, I am going to look at my dimensions. I have 2 terms by 2 terms. So I will set up 2 sets of parentheses. One set of parentheses is going to contain my height, and one set of parentheses is going to contain my width. So my height here is 3x plus 2. I just take those components and I write it in my first set of parentheses. Then I look at my width and I see that it's 4x minus 5. I am going to take that and write it in my second set of parentheses. And that is the area as a product. The other situation you might see for this standard is this. You've been given a set of binomials that are being multiplied. And you have to create an area model so that you can write the area as a sum. Before you dive into that, though, take this set of multiplied binomials and rewrite it where it says area as a product. This is already your area as a product, so you're halfway there. Then, because this is a binomial by a binomial, so 2 terms in each set of parentheses, I'm going to set up a rectangle that split into 2 on its height and 2 on its width. Now I'm going to take each term from my first binomial and make that the components of the height. So 2x squared minus 3. I'll do the same thing with my second binomial and make those terms the components of the base. So x plus 6y. Notice that the terms inside one set of parentheses stay together on one side of the area model. Now we need to multiply to fill in our 4 areas. In this box we have 2x squared times x. That will be 2x to the 3rd power. Next, up here, we have negative 3 times x. That will be negative 3x. Down here, we have 2x squared times 6y. The 2 and the 6 multiply together and we get 12. And then the x squared and the y, we can't combine those because they're different variables, so we just leave it as x squared y. Last but not least, we have negative 3 times 6y. That is negative 18y. I am almost ready to write my area as a sum, but I want to check for any like terms first as I do that. So I'll start with this 2x to the 3rd power. I don't see any other terms with x to the 3rd power, so I can just write that as the start of my area as a sum. Next, this 12x squared y, I don't see any other terms with x squared y, so I'm going to add that to my area as a sum. Next, I've got negative 3x. Again, I don't see any other terms with just x, so I add that to my area as a sum. And last but not least, negative 18y. There are no other terms in this area model with just a y, so I add that to my area as a sum. In this case, there were no like terms to combine, so my area as a sum is just 2x to the 3rd power plus 12x squared y minus 3x minus 18y.